So the converse of the Pythagorean theorem. So think about the word converse, like how we've used it. What does it basically mean? We're going to be doing the what?
Opposite.
Yeah, like the backwards version of it. We're going to be doing the Pythagorean theorem backwards, even if you're not sure what that means yet. So when we talk about the converse of the Pythagorean theorem, we already know that the Pythagorean theorem says that if the sum of the legs, not a squared plus a squared, if we were to take the legs and square them, and we took the sum of that, it would equal the square of the hypotenuse. A squared plus b squared is equal to c squared. But the converse of that theorem says that if the square of the longest side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. What that means is, let's say you've got three numbers, like 5, 12, and 13, and you're not sure if it's a right triangle. Well, we can check to see if it's a right triangle, because if we plug these numbers into the Pythagorean theorem and it ends up being a true statement, then guess what? This is a right triangle. That will only work on right triangle numbers. If not, it won't be a right triangle. So that's what we're going to do here, is we're going to check numbers. Now, can anyone tell me right away whether this is a right triangle?
Yeah.
How did you know that so quickly?
Because of the two.
So check that out. Think about that. Some people right away, just by memorizing those things that I said this is really important, they did no math and they knew this was a right triangle. That's what I'm saying. That's why it's a great idea to, so like let's say that they were going to do this on the test and they were like, hey, I'm going to do this on the test. I don't need them to show any work. They could just go like this, Pythagorean triple. Pythagorean triples only apply to right triangles. So if you plug these numbers in, if you're not sure, you can always plug the numbers in. And if it works out to be a true statement, then that is a right triangle. If a squared plus b squared is equal to c squared, then that's a right triangle. Are we okay with that idea?
Yes.
All right. Go back. Okay. Nope, you need. Okay. Here are some more triples. I say that because these are not as common as the other ones, but these are very common. Like these are super common ones that you can run across. So if you would like, these are more numbers, these are more Pythagorean triples. First of all, notice that they're all whole numbers. None of them are zero. And I will tell you right now that if you were to test these out and try them, that it would work out. So let's say I didn't know. Let's say that 8, 15, and 17, let's say I gave you a quiz question that said, is this a right triangle? So here's what we would do. We would put this in the Pythagorean theorem equation. So what numbers would I write here? Well, like what would I write out? Gio, help me out.
8 squared plus 15 squared equals 17 squared.
How did you know that 17 was the hypotenuse?
Because it's the largest.
It's the largest number. Keep going.
So then we work it out. I need to get 64 plus.
He's got it. Don't worry. He'll get it.
225.
Okay.
Oh, yeah.
You can take my word for it. 17 squared is 289. If you didn't know that, you could just work it out. 17 times 17. So now all I'm going to do is just add these together here. So when I add those together, I get 289 is equal to 289, which is a true statement. Those are equal. So that means the only reason that will happen is if this is a right triangle. If you add those together, those sides of a triangle, and it turns out, like if you're putting them in the Pythagorean theorem, and you add those two squares together, and what you get is something is equal to the same number, and that's a true statement, you've got a right triangle. If you take the two sides and square them, they will be equal to the hypotenuse squared. So I'm not going to do that for each one of these. I think you could go through those numbers. But the big thing to take from this, for me, is if I was giving advice, like let's say I was the one who was about to take this quiz, and I would say, hey, what would be a good strategy that would help me out for this? I would say, hey, you know what? Make myself like 2 note cards or 1 note card with all these triples on them. And then just make sure that I can name them off. If you can make yourself a list of these triples right away, you would cut down your work so much, because every time you saw 2 of these numbers in a right triangle, you'd already know the third number. You wouldn't have to do any math for that. These are triples. They help you out. Yes, sir?
So the triples they showed us yesterday and these are all...
Yes, and the truth be told, there is literally an infinite amount of triples. There's an infinite amount. I can't give you an entire list because it's like if I said, hey, if I asked you for a list of all the numbers. If I said, hey, can you give me a list of all the numbers? You can't, because there's an infinite amount of them. Same way with triples. Because if you think about it, if you took one of the triples and you multiplied by 2, there's another set of triples. If you took that one and you multiplied it by 2, there's another set of triples. You multiply all those numbers by 2, there's another set of triples. So there's literally an infinite amount of them getting bigger and bigger and bigger. Yes, sir?
Is there an easy way to tell when a set of numbers is a triple? Because I saw 8, 15, and 17, but I didn't know if it was like a triple.
So the way to check it, like let's say you weren't sure, is do exactly what we just did there. Now I know it's a triple because, first of all, it satisfies a squared plus b squared equals c squared. That's why I chose 8, 15, 17, because it's one that doesn't seem like it is, but in fact it is. I plugged it in, and it made a true statement. Therefore, it must be a Pythagorean triple. All the numbers are whole numbers. There's no non-zeros. And when I plug them into a squared plus b squared equals c squared, it satisfies that equation. Are we okay with that?
Yeah.
All right. Okay, here's one of my favorite parts of this. I'm going to start with nerd speak, and by the time I'm done, you're going to be like, oh, this totally makes sense. If the square of the longest side of a triangle is less than the sum of the squares of the other two sides, then the triangle is an acute triangle. So we already know how to identify if it's a right triangle, but now they're saying if we take a squared plus b squared, and c squared is less than the other two. Notice I used the greater than symbol, but really what that means there is c is the smaller number, right? If c is the smaller number, then it is an acute triangle. Now check it out. If I know some of you are still writing, but this totally makes sense here because I'm going to use my little whatever this thing is that I just rigged together. So if we take a squared, this one, and square it, plus b squared, this one, and square it, and it's equal to this one, it will be a right triangle. But if c, remember that c is the hypotenuse, right? This is this one right here, this black line going from here to here. If c were a smaller number, what kind of triangle is that? Acute. If c is the smaller, like literally you could do this with your hands. Like you could imagine a right triangle there, and you made c smaller, it makes an acute triangle. And I'm betting you can guess even what's going to come next after this slide. I showed you what happens when a squared plus b squared is equal to c squared, right triangle. When a squared plus b squared, when these two are bigger than this one, so that means this is the small piece here, when that gets small, we get acute. I bet using that idea, you can already figure out where this is going next. So if you haven't, you'll see on the next slide. The next one says, if the square of the longest side of a triangle is greater than the sum of the squares of the two other sides, then the triangle is an obtuse. So if we take a squared plus b squared, and we also do c squared, and c squared ends up being a greater number, c is the big part, well, check it out. Let me do the same thing here. I'm going to hold up my triangle, and remember, c is the hypotenuse. We have to keep talking. That's why I always talk about c. C is so important. If c is the bigger part, well, look what kind of triangle I just made. Obtuse. All I did was make c bigger. That's all I did. Is I took a right triangle and I made c bigger. Well, that means that I've got an obtuse triangle. No matter how much bigger it gets, it's still obtuse, obtuse, obtuse. No matter what, then it's going to be an obtuse triangle. So remember, when you're doing these, if you were trying to figure them out, you plug them into the equation, you're trying to figure out what triangle it is, you can figure out whether it's acute, whether it's a right triangle, whether it's obtuse, just based on those numbers. Just figure out, well, is c squared equal to a squared plus b squared? Well, that's a right triangle. If c is the smaller part, if you notice that c squared is smaller than a squared plus b squared, well, then it's an acute triangle. If c squared is bigger than a squared plus b squared, then it's an obtuse triangle. Does that make sense? Are we okay with that?
Yeah.
Okay, because we're going to play with some numbers and actually figure some stuff out. All right, so the sides of a triangle have the lengths given. Is the triangle acute, right, or obtuse? First of all, do we have anything that you can see up there that is a Pythagorean triple? Was 5, 6, 8 one of ours? Let me just go back a slide. So 5, 6, 8 did not look like it was one of the ones we did yesterday. So I just say that because if you know it, great. If not, don't worry. You can do this the long way. We can figure it out. So we don't know whether they are acute, right, or obtuse. I'm not sure. But we can figure it out. Let's do these off to the side here. Let's start with A. Somebody talk to me about A. How can I figure out what kind of triangle it is? Gio, start us off.
What I did is I did 20 squared plus 21 squared equals 29 squared.
Now, don't get me wrong. So we're going to set it up as if they are equal. They may not end up being equal. It may turn out that these are not, in fact, equal. But let's set it up that way, like we're using the equation, and then we'll change that equal if we need to.
And then I got, for the 20 squared, I got 400.
Okay?
21 squared, I got 441.
Plus 441
Equals 841.
is equal to 841. What is 400 plus 441?
841.
So we get 841 is equal to 841. Is that a true statement?
Yeah.
Okay, so what kind of triangle is this?
Right.
This is a right triangle because those two things are equal to each other. And we did that using this information right there. We're going to go on to B. So we get, how did you know, by the way, I can do that too. How did you know that so quickly?
Me?
Yeah, you said obtuse right away. And by the way, it's actually, this one should be like that using logic.
Because like the last number is bigger and then the first two are the same.
Okay, so he said on the first one, if I square this and I square this, it'll be equal to this squared. And all of a sudden, this number just got bigger.
Yeah.
The C just got bigger. So what does that tell me?
It's
It's obtuse. But let's actually do it with some numbers. So let's just do this. 20 squared plus 21 squared is equal to 30 squared. It's just a great way to check our numbers to go, okay, so we get 400. We already know that. And 441, Gio gave us that. What's 30 squared?
900.
900. So we get 841 is equal to 900. Is that true?
No.
No, we need to replace this with a different symbol. So 841 is not equal to 900. What do I put in there? Greater than, less than? What do I put in?
Less than 841.
So notice that this is the C. That part over there is the C. C is the bigger part. Therefore, this is obtuse. Let's go on to C. Somebody new. Hook me up. Yes, sir.
Okay, so AB, or 5 squared plus 6 squared is equal to 8 squared. So I got 25 plus 36 is equal to 64. And it's not true.
What is 25 plus 36 equal?
61. So it's cube.
Okay, so they are not equal to each other. In fact, what symbol should go there?
It's greater. No. Yeah, less than.
Wouldn't it be obtuse?
I don't know, you tell me. It's obtuse because the right-hand side, the C part, is bigger. If C is bigger, it's definitely obtuse. Okay, let's go on to D. We'll do D over here.
Wait, D can't be a right triangle, right?
It can be, it cannot be a Pythagorean triple. Remember, so a Pythagorean triple is a very special kind. So he's saying, he looked at these and goes, hey, this can't be a right triangle because of that middle number there. It's not that it can't be a right triangle, but those are definitely not a Pythagorean triple, I'll tell you that. It's not that special set of numbers. So we've got 4 squared plus 4 square root of 3 squared is equal to 8 squared. Now, when it comes to this, I'll tell you, my being worried for you is only here. This is the only part that I'm worried about people in this room that I go, just because some of you are like, nope, I figured that out yesterday. I know how to do that now. I'm not worried. Some of you will be like, I still don't get it. So let's get it. If not, you didn't get it yesterday, let's get it today. What am I going to do first? Yes, sir.
You're gonna write it out the long way.
Okay, well, let's get the 16 out of the way, and then we'll do this. You're right. We're going to write this. I'm going to write this out the long way. Is equal to 64. It's that middle thing that I'm like, eek, I don't want to deal with that. That's ugly. So, as he said, I'm going to move off to the side and deal with that. It's 4 square root of 3 times 4 square root of 3 And how do I multiply those numbers? Do I FOIL them?
No, outside, the outside,
Good. Outside numbers times outside numbers, which gives me what? Inside numbers times inside numbers, which gives me the square root of 9. And the square root of 9 is? And 16 times 3 is?
Wait, how,
48.
3 times 6.
Is that right?
Yeah?
Yeah.
So this becomes 16 plus 48. Gio, you have a question. I'll get to it in just a second, okay? What is 16 plus 48? Let's do that. What kind of triangle is this? It's a right triangle. Now, Gio, I'm guessing your question is with something we did over here on the left-hand side, correct?
yeah.
Which part?
I just don't, because like I thought we did the foil and that's all confused on the part.
So here's where the numbers came from. Outside number times outside number became this. Inside number times inside number became this. The square root of 9 is 3. And then 16 times 3 is 48.
Oh, okay.
I'm telling you now, like I go, you shouldn't only expect these kind of things from now on. Like I don't feel like that should be a real problem for you. You may not love it, but you should be like, yeah, I can do that. You're not only going to see this all the time in here, like you'll see that all the time in Algebra 2. Whether it's regular or honors, no matter what you're going on to, you're going to see that all the time. They're going to expect that you know that, and I don't want you leaving here going, I don't know how to do that. You go, even if you didn't get an Algebra 1, you got it here. And hopefully you're like, yeah, I got that now. Last but not least, we've got E. So we've got 1 squared plus 3 squared is equal to 10 squared. Square root of 10 squared. So 1 squared is? 3 squared is equal to the square root of 10 squared. Well, 9 and 1 is 10. So 10 is equal to the square root of 10 squared. And if you want to figure out what the square root of 10 squared is, it is the square root of 10 times the square root of 10, which becomes what? The square root of 100. And what is the square root of 100? 10. So what kind of triangle is this?
Right.
It's a right triangle as well. Okay, good news is that we've basically done all the work we need to do. This slide is just a summary of what we just said. So these are how we decide whether a triangle is acute, obtuse, or whether it's right. If c squared is equal to a squared plus b squared, we learned that it's a right triangle. If c squared is less than a squared plus b squared, meaning c is the smaller number, well then c is the small piece right here. It makes an acute triangle. That's all you need to remember. Again, if you need to be like using your fingers to think about that, like, well, what happens when c is smaller? Use your fingers. You could do that and go like, okay, I have a right triangle. Like if you make an L with your left hand, you've basically got 2 parts of a right triangle. You just need to imagine the third line. Now making the third line smaller, that C smaller, you can see in your hand, well, what kind of triangle would that be? That would be an acute triangle. Here, if C becomes the larger part, notice that C has become larger, then we have an obtuse triangle because this has become bigger here. We've got a bigger C, so that means it has become an obtuse triangle. Any questions on any of those? Because you should actually be able to finish your homework in class today because that's all we are doing today. We are going to hit 7-3 tomorrow. Now, I will give you a heads up. 7-1 and 7-2, I think, are the easier part of this. I'm going to tell you now that I think 7-3 is more difficult. So if you need to find some focus, find it for tomorrow because tomorrow is the part that I will take slowly, but it's certainly the harder of the 3 lessons. All right, get your homework done before you start doing anything else.